We will now use the concepts of energy that we developed earlier to solve problems. Let's start with this problem. A constant force of 75 Newton acts on an object initially at rest and acts through a parallel distance of 0.6 meter. What is the final kinetic energy of the object? B. If the object has a mass of 0.2 kilogram, what is its final speed? What is the work that would be required to bring it to rest? Well, what all this problem involves is the basic definition of kinetic energy. All right, what do we have? We have a force is 75 Newton. The displacement produced by that force is 0.6 meter on a mass m equal to 0.2 kilogram. So what is the work done? The work done is force multiplied by displacement in the direction of the force, that is 75 Newton times 0.6 meter, that is 45 joules. What are we supposed to do? What is the final kinetic energy of the object? What is the definition of kinetic energy? Kinetic energy is a measure of the work done to give an object a velocity v. So this is the measure of the work done on the object. So the work done on the object is a measure of its kinetic energy. K, kinetic energy, is a measure of the work done on the object. And therefore, the kinetic energy of the object is 45 joules. Now, if the kinetic energy of the object is 45 joules, what is the final velocity? Kinetic energy is a measure of the work done to give an object a velocity v. And when the object has a velocity v, its kinetic energy will be 1/2 mv squared. Is that right? So kinetic energy equal to 1/2 mv squared. We know the amount of kinetic energy, that is 45 joules. We know the mass of the object, that is 0.2 kilogram. And therefore we say 1/2 mv squared equal to 45 joules, and solve for v squared from there. Look at the way I'm going to solve for v squared. It will be 2 multiplied by 45 divided by m. I hope you can follow that calculation like this. 2 multiplied by 45 divided by m will be v squared. And that gives me v squared equal to 450 meter per second squared. And so what is v? V is the square root of that, which is 21.2 meter per second. Okay, what's the answer for C part? What is the work that needs to be done to bring this object to rest? If you remember the definition of kinetic energy that we used, kinetic energy is a measure of the work done to give an object a velocity v. That is one definition. It is also equal to the work that needs to be done to bring the object to rest. So, if our object has a kinetic energy of 45 joules, what is the amount of work that you need to do to bring this object to rest? It is opposite to that. It should be negative 45 joules. 45 joules of work is done to give the object a velocity of 21.2 meter per second. To reduce this velocity to 0, the work that needs to be done will be opposite, will be negative 45 joules. Okay, let's do another problem. A 600-gram object with an initial velocity of 3 meters per second in the positive x direction is acted upon by a force in the direction of motion. The force does 2.5 joules of work. What is the final velocity of the object? Well, the force does 2.5 joules of work. What does that 2.5 joules equal to? When the force does 2.5 joules of work, that is a measure of the increase in kinetic energy, the gain in kinetic energy. The object is moving with a certain speed, and on that moving object, a force does work. How much work? 2.5 joules of work. That means that amount of work done increases its kinetic energy. So 2.5 joules is a measure of the increase in kinetic energy. Let's take our data. The mass of the object is 600 gram, that is 0.6 kilogram. The initial velocity is 3 meters per second, and the net work done is 2.5 joules. If K1 is the initial kinetic energy and K2 is the final kinetic energy, the change in energy delta K must be equal to the net work done by the external force. Is that right? Yes. So delta E, the change in energy, is K2 minus K1. Now K1 is 1/2 mv0 squared, the initial kinetic energy. Because the object is moving with this velocity 3 meters per second, it has an initial kinetic energy 1/2 mv0 squared. Let's use those values. M is 0.6 kilogram, V0 is 3 meters per second, and therefore the initial kinetic energy is 2.7 joules. Therefore, according to work energy theorem, delta E equal to the change in the energy is a measure of the net work done on the object. So K2 minus K1 equal to the net work done. How much is the net work done? Is 2.5 joules. So K2 minus K1, K1 is 2.7 joules, therefore K2 minus K1 is 2.5 joules, and that gives you your final kinetic energy. Therefore K2 equal to 5.2 joules. What are we supposed to find? We need to find the final velocity. We know the final kinetic energy. If the final velocity is V2 or V, then this final kinetic energy will be 1/2 mv squared. Alright, let's do that here. If V is the final velocity, then K2 will be 1/2 mv squared. And that K2 equal to 5.2 joules. And now, you know the mass of the object. The only unknown quantity there is V. Solve for V. Look at that again. I solved for V squared. V squared is 2 times 5.2 divided by M. And M we know is 0.6 kilogram. So that will be 2 times 5.2 is 10.4. M is 0.6 kilogram, and therefore V squared is 17.3 meter per second squared. V is the square root of that is 4.2 meter per second. I hope you understood the method which we used to solve the problem. It is the work energy theorem. The change in the energy is a measure of the work done by the external force. Another problem. A girl swings